Okay, the main idea for this video is not going to be converting from factored form to standard form, but I want to start off here. The main idea for this video is going to be factoring quadratics, and that's going to be when a is equal to 1, and we're going to do some when a is not equal to 1 as well. So I want to give you a little bit of background between from when we started with converting from factored form to standard form, because how did we get to standard form is what I really want you to think about when you're working on factoring. So we started off with these two factors. So let's just say that we started off with factors of x minus 2 and x plus 3. To get that into standard form, we had to take those two things and multiply them together. So no matter what way you learned to multiply two binomials together, you could have used FOIL, you could have used the box method, or you could have used something called double distribution, which is really what we're doing. We're just putting it in a box here to do that. So what I want you to think about when you're factoring is, how are we going to get our trinomial back into our two binomials? That's what we're always aiming to do when we're factoring. So I just want to bring this back to you to kind of give you an idea of where you should be heading with your factoring. Okay, so factoring something that has three terms, that's what we're focusing on here. We're factoring a trinomial that happens to be a quadratic. A quadratic always has an x squared term. So to factor something that has three terms, and we want to make it into two binomials, these are going to be our factors. There's a trick to do that. Okay, and the trick is find two numbers that multiply to the c value, but those have to add to the a value. Okay, so let's review what we mean by a, b, and c. A is the number in front of the x squared, b is the number in front of the x term, and c is the constant number with no variable. So this will be a, b, and c. And in this case, we know that our c value is -2 and our b value is -1. So then what I would do is start listing all of the factors of -2. What two numbers multiply to -2? These are a couple of sets right here. Now, if the number was larger, of course, you'd have to think of a lot more number pairs. But we want to make sure that when the numbers add together, it gets to -1, or adds sums to -1, and it looks like that's going to be this. Okay, so all we have to do is do our two binomials using the numbers that we came up with. So x minus 2 times x plus 1 will help us arrive back here at this trinomial if we were to put those two factors into the box, or FOIL them, or double distribute. Okay, let's find one that's a little bit more challenging. Let's try this one down here, number 18 here. So if we look at this one, we're looking for two numbers that multiply to 63, that's our c value, and two numbers, those same two numbers that we picked for 63 that are multiplied together, have to add to -16. Okay, so let's think of all the numbers that go into 63. I think 21 times 3, 9 times 7, and then of course -21 times -3 would give us positive 63, and -9 times -7 would also give us positive 63. And it happens that these two, when we add them together, would give us -16 when we add them. Okay, so our final answer for our two factors is going to be x minus 9 and x minus 7. Now you can always check your work, of course, and put those two factors into a box method, or FOIL them, or however you want to double distribute, but this is going to be x squared minus 9x minus 7x plus 63, because those two get multiplied together for this. And then when we combine like terms, we would get right back to what we started with. Okay, so this is factoring when a is equal to 1. It's pretty straightforward because you're just looking for two numbers that multiply to the c value, in this case was 63, and two numbers, sorry, I made an error there, that was going to be our b value. Our b value is -16, and the numbers have to add together to come up with that number. Okay, So let's elevate our game a little bit and move on to when a is not equal to 1. And I have these 6 steps drawn out, listed here. And basically we're just going to draw a large X. So I'm talking really large, like large. And what we're going to do is we're going to multiply a times c and put that number in the top. So first of all, identifying a, b, and c is a good idea. So a, b, and c. And we need to multiply 3 times negative 3. That gives us negative 9. Remember, this is a times c. And then in the denominator, sorry, not the denominator, but the bottom here of our x, we're going to put the negative 8. That's our b value. Okay? Now I have a dot here to remind us that the two factors that we're going to come up with have to multiply to this negative 9, and those same numbers have to add to negative 8. Okay, so multiplying those together, we got negative 9, and that's why we're looking here to make them add to negative 8. And we're looking for two factors still. So going back to our list up here, I think I've done steps 1, 2, and 3. Now for step 4, I need to find two numbers that multiply to that negative 9 value, but sum to b. So we can think of lots of pairs, so negative 3, positive 3, negative 9, positive 1, or negative 1 and positive 9. I think these are the factor sets that would multiply to negative 9, but the value that we want them to be when we add them is negative 8. So we would have to pick this set of factors right here. So we're going to put one here and one here. Okay, so we did step 4. Step 5 says write the two numbers on the right and the left. Doesn't matter which one, goes where. Divide the numbers by a. Okay, so a, we already know what a is. That's 3. And the next step is going to be to simplify the fractions on the left and the right. Those are going to become our two binomials. So good, we're really close to getting our answer here. This cannot be simplified anymore. And this can be simplified a little bit because 3 goes into negative 9 negative 3 times. So now I have negative 3 over 1. And the way that we're going to write these numbers, these are actually going to become our binomials if we remember that we want to put the variable with the number in the denominator, and that variable 3x plus 1, this thing here becomes our first binomial, and this one here, this actually has a negative 3 here, so this is going to end up being x in the denominator minus 3. Now, the way you can check this again is to put it in to your box or FOIL it or double distribute, and that will get you back to your original trinomial. Okay? Trinomial just means that we have 3 terms. This happens to be a quadratic because it has an x squared term. All right, so these are the steps for factoring when a is not equal to 1. Now, to elevate our game even further, we have some problems that we can do that have a greatest common factor. So let's take a look at one of these type problems. Let's look at perhaps number 17 here. I'm going to make this a little larger for those of you watching on a small device. Might be helpful. So I immediately noticed that 12, 80, and 48 have something in common. They are all divisible by 4. Okay, so I can divide each one of these by 4 to reduce the numbers that I'm going to get when I start factoring. So first thing I want to do is factor out the GCF. Okay, greatest common factor. If you can think of a bigger number than 4, obviously you would use that number, but 6 goes into this and this. I don't think 6 goes into 80, so that's why I didn't use 6. Okay, so now I have my 4, and I'm going to rewrite my new trinomial because 4 goes into 12 3 times, and 4 goes into 80 20 times, but it's a negative there. Don't forget your variable, and then this is going to be 12. Okay, so now we have another trinomial here that the a value is not 1. So that means that we need to bring back our steps for factoring when a is not 1. Okay, so the first thing I'm going to do is I'm going to draw my big X. The next thing I'm going to do is multiply a times c. Now my new a value is no longer 12. Okay, so basically we ignore the original equation or expression until the end when we want to check it. Right now our a value is this 3, the b value is the negative 20, and the c value is the 12. Okay, so a times c is going to get me positive 36 in the top. The b value is negative 20. That goes in the bottom. You have to write two numbers that multiply to this number. Remember, multiply is this one and add is this one. So two numbers that can fulfill these. Well, 36, I can think of 9 times 4, but that doesn't add to negative 20. Negative 9 and negative 4 won't add to negative 20 either. What about 12 times 3? Well, that's going to be 15, so that's not going to work. 18 times 2. Now 18 times 2 would add to positive 20, so I'm going to have to make both of those negative in order to make them result in a positive 36 when I multiply them and a negative 20 when I add them. So negative 18 and negative 2. And then just remember that we're dividing by a, and our a value now is this 3. Okay, so we're dividing by that. And if we can, we're going to simplify the fractions. So the step 6 in our steps down here say simplify the fractions on the left and the right. Those are going to become our two binomials. So if I can simplify it, I will. This one actually cannot be simplified. I'm just going to throw the x next to the number in the denominator. This one can be simplified because 3 goes into 18 6 times. That's going to end up having my variable there. Now, remember when you finalize your answer that 4 is still part of our final answer. 4 is the GCF, so we're going to keep that as part of our final answer. And we're just going to take this and turn it into a binomial, x from the denominator, negative 6 from the numerator, and this is going to be our 3x minus 2. So our final answer for the factors of the original expression is going to be 4 times the binomial x minus 6 times the binomial 3x minus 2. So you want to keep factoring until you cannot factor any further. You can't factor x minus 6 any further, and you can't factor 3x minus 2 any further. And so following these steps is going to help you find your way to the factors for any problem when a is not equal to 1. I hope this video has been helpful to you.